Okay. So chapter 2, you are going to see some more familiar topics. Okay. But here again, we're going to expand on these familiar topics, but we're still going to move quickly. All right. Not as quickly as chapter 1, but still, we're going to be moving right along. Okay. So the first thing we want to talk about are quadratic functions. Okay, you did an entire chapter on quadratic functions in Algebra 2. We've talked already about what their parent graph looks like, okay, and how to apply the transformations to them. You know how to recognize a quadratic function. Okay. Ax squared plus bx plus c. Basically, if your highest degree of your variable is 2, don't know what that is. Then you have a quadratic. Okay. Now, when you graph these in Algebra 2, you figured out where the vertex was, and then you picked some points from there, right? We just spent an entire chapter where a big part of it was transformations of parent functions, okay? So when we look at graphing our quadratics, we're going to look at, a parent function being transformed. So the form that we are going to work with is this. We're going to call this standard form, okay? Last year you probably called it vertex form, right? A times the quantity x minus h squared plus k, all right? Why did you call this vertex form, okay? If we look at this equation, all right, first of all, A, that's going to tell us if we stretch or shrink vertically, right? H tells us we move which way. Okay, in this case, it'd be to the right H, correct? And then this plus K tells us up K, right? And so when we take a quadratic and we shift the vertex and then we draw it, correct? So this HK is telling you where your vertex has been shifted to. So you can simply look at H and K and know your vertex. Okay. Okay, we talked about symmetry last chapter. Okay, we talked about an even function having symmetry about the y-axis. Okay. Our parent function x squared is an even function. That's something that you studied for your test. If a quadratic has been shifted to the right or left of the y-axis, it's no longer even, but it still has symmetry. Okay, a quadratic will always have symmetry about a vertical line. We call it the axis of symmetry. The vertical line goes through the vertex, so it's just the line x equals h. Whatever your x coordinate is for your vertex, that vertical line is going through it. Okay, so that's something you'll need to identify. Not only the vertex, but the axis of symmetry. What does it mean if our A is positive? What does it mean if A is positive? Okay, if it's positive, whether it's stretched or shrunk, it's going to open up, right? And no matter what, no matter what, if A is negative, then our parabola is going to open down. Okay. This is not only going to be important for graphing, but later on as well. Now, what would we call, make you think about some vocabulary words back in chapter 1. What do we call the vertex when A opens up? What is that called when we switch from decreasing to increasing? What's this point when we switch from decreasing to increasing? It's the lowest point. What's another word for that? Starts with an M. Minimum. Okay. I don't know. I should have a button here to make my screen go up, but I don't know where that is. So, I'm sorry. I'm trying. There it is. There you go. Okay. Okay. And if A is negative, what do we call the vertex? Okay. That could be important if we have like a real life situation, like a word problem that's modeled as quadratic. Okay? Like maybe a ball thrown up in the air. Okay? Now, we know how to graph quadratics quickly based on our transformations. Okay? So like I said before, if we are in standard form, we can easily shift to our vertex HK and then apply a stretch or shrink if need be. Okay? So, if our quadratic is not in this form, we need to get it in this form. And we have a strategy to help us get it in this form. Does anybody remember what that's called? If I have a trinomial, how do I get it to look like this? Something you asked about on the summer packet. If it is not in standard form, we have to force it to be a perfect square, so we have to complete the square. I will remind you how to do this. Do not forget after today. This will be an important tool not only for this chapter, but chapters to come. All right? So, here is x squared minus 6x minus 1. We know it's a quadratic. All right? So what we need to do is we need to complete the square. First of all, is this a perfect square trinomial? What do I mean by a perfect square trinomial? Okay. Not quite. X squared minus 4x plus 4 is a perfect square trinomial because we can factor it to a binomial square. Okay? If it is not in this form, then we complete the square. So, this does not factor to something, a binomial square. Okay? So what we're going to do, we need to, first of all, you can only complete the square if you have a leading coefficient of 1. We have a leading coefficient of 1, so we are safe. So what we're going to do, we're going to group anything with an x together, and we're going to leave our constant outside. All right, we're going to worry about that last. Okay? We are going to add something to our x squared and x term here. But can I just add something to an equation? I can't just add something, okay? That's changing the equation. So if I add something, what do I need to do to balance it out? Subtract that same value. If I add 5 and subtract 5, that's the same as adding 0, right? So we're not changing the value of our equation. Okay, now I need to remember what number goes here. Anybody remember? We take b over 2. Which one is b? -6. And what's b over 2? It's -3. b over 2 is -3, and then we square that number. So we're adding and subtracting 9. We take b over 2, and we square it for our missing number. Okay. So now, what does x squared minus 6x plus 9, what does that factor to? X minus 3 times x minus 3, right? That was the whole point, okay? Notice how this number matches this number. See that? That will happen every time. And then what do I have out here? We have minus 10. So now we have our quadratic in standard form.
So what would you do if you had a number in front of the x squared?
That is an excellent question. My next example is going to address that. Okay? Now, let's just talk about this in terms of what the graph is going to look like. Where is our vertex? Three, -10. We are shifting to the right 3 and down 10. So +3, -10. Okay. Where is our axis of symmetry? X equals 3. All right, because if we were to graph this, okay, our vertex is shifted right 3 and down 10, right? Our axis of symmetry cuts through the vertex. Since our vertex is at 3, -10, our axis of symmetry is x equals 3. It's that vertical line. Okay. All right. Now, let's talk about what happens if our leading coefficient is not 1. I just told you we can't complete the square if our leading coefficient is not 1. Okay? Now I'm going to go back to that previous slide very quickly. Notice how I grouped my x terms together in parentheses. Okay? And then I separated it out from any constants. All right? We're going to do the same thing here, but I don't like that 2. That 2 can't be there if we're going to complete the square with that b over 2. So what we're going to have to do is we're going to have to factor it out. So only factor it out of your x terms. Still leave this +7 because we want it to be on the outside for our vertical shift. Okay? So we're still going to add a number and subtract a number to keep our equation balanced. We're not going to change it at all.
Would you still do that if the 8x was, say, 7x, and then you just put a fraction?
Right. No matter whatever your leading coefficient is, if it's not a positive one, you're going to have to factor that value out of the x squared and the x term. Okay, but you'll leave the constant outside. Okay, so even if this is a negative 1x squared, you'll still have to factor out that negative 1. It has to be a positive 1. Okay, so now, what completes our square? What is b over 2? 2. So we're going to put 2 squared in for our blank. All right? What number am I subtracting, though? What number did I really add to our equation? 8. This 4 is being multiplied to the 2. Do you agree? So we aren't really adding 4. We have a 4 written here, but we're really adding 8. So we're going to have to subtract 8. Okay. So our quadratic is 2 times, what is this factor to? X plus 2, the quantity squared. And then we have minus 1. Where is our vertex?
Negative.
Very good. We shift left 2 and down 1, so negative 2, negative 1. And our axis of symmetry is where? X equals negative 2. Okay. Since we are so awesome at our transformations, okay, let's go ahead and graph this. We have to shift to the left 2 and down 1. Now, that vertical stretch of 2, what does that do to our points? How do I apply that? Okay, we have to multiply our y coordinates by, in this case, 2. So our parent function usually has our vertex at 0, 0, and points at 1, 1, and negative 1. But those have to be stretched by 2. So instead of over and up 1, we're going to stretch them by 2. So we now have a skinnier parabola. Ooh, that was bad. And here is our axis of symmetry. Okay, be careful when you complete the square. If it is not a positive 1 in front of x squared, you need to factor it out of the x terms. Please also be careful when you decide what number to subtract, because if there's anything you factored out, that is affecting that number. Okay? So you will have quite a few problems where you're going to need to complete the square. Not quite a few, but a good number, maybe 4 or 5. All right? You will also come across problems that look like this. Write the standard form of the equation of a parabola that has a vertex of negative 4, 11, and it passes through the point negative 6, 15. Okay. So first of all, they want it in standard form, which means we need it to look like f of x equals a times x minus h squared plus k. We need to figure out what a, h, and k are. Do we know any of those?
We know H and K because that's the vertex.
Okay, they gave us the vertex, so we know what h and k are, correct? So for right now, I'm going to go ahead and write this as a y. We know y equals a times x plus 4, very good, squared, and then plus 11. How will I figure out A? Okay, we have another point on our parabola, right? That point should satisfy our equation. So if we plug in our point -615, we should be able to solve for A. Now before we solve for A, I want us to determine, is A going to be positive or negative? If our vertex is at -411 and it passes through a point -615,
Positive.
Positive.
it's going to be positive, right? Because the y value is bigger, right? Okay, so it's opening up because that second point has a higher y value, all right? So we should get a positive A. Hopefully our work reflects that, okay? So let's plug in the point -615. So y is 15. We don't know A. X is -6. Okay, please be careful of your order of operations, okay? The little mistakes got some of you on the test, okay? A lot of little mistakes add up after a while, so please be careful with your order of operations. Okay, -6 plus 4 is squared. Notice how I don't need a calculator to do any of this, okay? Bring our 11 over. And what is A? 1. Okay? So in standard form, we have f of x is 1 times x plus 4 squared plus 11. If you write 1 right here, that's fine. It's being redundant though, because we can assume if there's nothing there, it's 1. But if you write 1, I am not going to fault you for it. Okay.
Wait, so you just brought 4 over to the A. Maybe 6 plus 4 squared.
Well, because this is A times 4,
Oh,
right? Yeah. So it's easier to write 4A. Yeah. Any questions? Okay. I believe you have some graphs on your homework, but it's just like what we did on our test yesterday. If I ask you to graph, I want you to write it in standard form first if it is not, and use that to find the vertex, x-intercepts, and axis of symmetry. Okay, x-intercepts will help you. Tomorrow and Thursday, tomorrow and Thursday, you will need your graphing calculator both days. Please make sure you have it tomorrow because we are going to do an activity with it. Okay? You have a good 12, 13 minutes to work on homework. Please use it wisely.